In this video, I'm going to show you some more examples of finding integral of trigonometric functions using the substitution method. Let us start by this example. Integral of secant to the 2 over tangent to the 2 d theta. As I mentioned before, one of the problems that the students struggle with finding the integrals with substitution method, one of the reasons is that they don't remember derivative formulas. Derivative formulas are very fundamental for applying substitution method, because you want to choose something as u and derivative of that u should exist in your expression. And if you don't remember integral derivative formulas, then you have problem with choosing u properly. When I look at this expression secant to the 2 over tangent to the 2, I notice I have secant, I have tangent. Immediately in my head I am checking what was derivative of secant. Derivative of secant is secant times tan. What is derivative of tan? Derivative of tan is secant to the 2. And immediately I notice I have secant to the 2. So what is u in this example? U is tangent theta. Attention, not all of this. I'm not going to choose all of the denominator as u. Just tangent. Why? Because derivative of tangent, only tangent theta, is exactly secant to the 2 that we have in numerator. So du is going to be secant to the 2 d theta. Now let's do the substitution. So we have secant to the 2 over u to the 2 times by, we forgot to solve this for d theta. D theta would be du over secant to the 2. We want to replace everything in terms of u. So we replace d theta in terms of du. D theta is du over secant to the 2. Du over secant to the 2. Secant to the 2 with secant to the 2 cancels, and then we have du over u to the 2. For finding integral of du over u to the 2, let me show you that here. U to the 2 can be moved to the numerator. We can write it this way. And the integral of u to the negative 2 based on the power rule would be u to the negative 1 over negative 1. We add 1 to the power based on the integral of power functions. U to the negative 1 over negative 1 plus c. And this can be written, of course, in the form of negative 1 over u. U to the negative 1 means that move u to the denominator, and don't forget to put this negative here. So finally, integral of the du over u to the 2 is negative 1 over u. So the answer of this integral is negative 1 over u. But u originally was tangent. So negative 1 over tangent theta plus c. And this is the answer of that integral. Now, attention. 1 over tangent is reciprocal of tangent. And if you remember from trig identities, cotangent and tangent are reciprocal of each other. So if you like, you can write your final answer. This is optional. This is not really necessary. But if you like, you can write this answer as negative cotangent theta plus c. So the answer of integral of secant to the 2 over tangent to the 2 theta d theta is negative cotangent theta. Before I finish this example and jump to the next example, let me show you another method for finding this integral. Maybe you are finding that method interesting. For finding integral of secant to the 2 over tangent to the 2 d theta, also you can use trig identities to find this integral. Secant, if you remember, secant is 1 over cosine. So secant to the 2 is 1 over cosine to the 2. Tangent to the 2, tangent is sine over cosine. So tangent to the 2 is sine squared over cosine squared. So far we did nothing. Just we replaced secant with its equivalent expression, which is 1 over cosine. So secant to the 2 is 1 over cosine to the 2, and we did similar thing for tangent. Tangent is sine over cosine, so tangent to the 2 is sine to the 2 over cosine to the 2. Now, this simply can be written as 1 over sine to the 2 d theta. Let me explain what happened from here to here. We have a fraction divided by another fraction. So basically you have to multiply this by reciprocal of this. So it means that 1 over cosine to the 2 times by reciprocal of the denominator, which would be cosine to the 2 over sine to the 2. Cosine to the 2 with cosine to the 2 cancels, and then you get 1 over sine to the 2. So it should be very clear for you. Or another way that you can get from this to this is to know that when you divide a fraction by another fraction, if the denominator is the same as the denominator and numerator, you can cancel them. And then you have 1 over sine to the 2. Same expression. This way is faster. So during doing these questions, you can learn these tricks in algebra as well. Okay, now we have integral of 1 over sine to the 2. 1 over sine is cosecant. So 1 over sine to the 2 is basically cosecant squared. And now, if you remember from integral formulas, integral of cosecant squared is negative cotangent theta. And this answer is exactly same answer that we get from the other method. So this is method 2 for that question. Now take a look at this example. What is integral of dx over cosine squared x radical 2 plus tangent x? We have nothing in numerator, just we have 1 dx over cosine squared x radical 2 plus tangent x. We know that something in denominator is u, but which part? Cosine or this, or all of radical? Because 2 plus tangent x is in the denominator and also is inside the radical, so probably it's better to first try this expression as u. Hopefully its derivative is in the integrand. So we choose 2 plus tangent x as u, and then we get du, derivative of u. Derivative of tangent, derivative of 2 is 0, so derivative of tangent is secant squared. X, not theta, secant squared x dx. Maybe this seems a little disappointing because we are looking for secant squared here and we don't have secant squared, so we think, oh, maybe we are wrong, we have to change our substitution. But wait a minute, secant squared is 1 over cosine to the 2. Remember, secant x is 1 over cosine. This is definition of secant. Secant is reciprocal of cosine. So basically secant squared is exactly 1 over cosine to the 2. Exactly, we have 1 over cosine to the 2 here. 1 over cosine to the 2 is ready for you here. So this shows that our substitution is going to work. So basically this is the same as this. Now we solve this for dx. So dx equals, this is x. dx equals cosine to the 2x du. We solve this for dx and this is dx. Now let's apply the changes. dx in numerator is cosine squared x du over cosine squared x, which cosine squared with cosine squared cancels, and radical u. So we have integral du over radical u. For finding the integral of du over radical u, you can write this simply as u to the negative 1/2 du. Radical u is to u to the 1/2. We move it to the top, so it's u to the negative 1/2. And the reason that we do this is that we want to use the power rule in integral formulas to find this integral. Based on the power rule formula for integrals, the integral of u to the negative 1/2 would be u to the negative 1/2 plus 1, which is 1/2, all over 1/2 plus c. And this can be written simply as 2u to the 1/2. 2u to the 1/2 plus c. And u to the 1/2 is basically 2 radical u. But radical u means radical of this expression because u is 2 plus tangent x. So the final answer is 2 radical 2 plus tangent x plus c. And this is the answer of that integral that we had originally. Now look at this example. What is the integral of secant theta tangent theta over 1 plus secant theta? As usual, we try to choose something in denominator u. If it doesn't work, maybe something in numerator is u. We have to try different things. Let's see. U is 1 plus secant theta. This is our first guess. du, derivative of u. If you remember derivative formulas, derivative of secant is exactly secant times tan. And this is exactly what we have in numerator. So from this d theta would be du over secant theta tangent theta. At first, this example seems really challenging, but as you can see, with a simple substitution, you can find the answer. Now, let's do the substitution. Integral of secant theta tangent theta all over u times d theta, which is du over secant theta tangent theta. This cancels with this, and we have du over u. Integral of du over u is ln of absolute of u, and u in this case is ln of absolute of 1 plus secant theta plus c. Let me show you a trick that can help you to find integrals like this without doing any substitution. Whenever you see a fraction times dx or du or whatever, this is the first thing that we always try. We suppose this to be u, and if the derivative of the denominator is exactly in the numerator, like this example that we have here, so if whatever is here, its derivative is exactly in numerator, so if we have u here and u prime is in numerator, then the answer is always ln of the denominator, so ln of u. So you don't need really to write all of this substitution. Simply, in your head, you can check by yourself. We suppose this u. So we suppose this u. You don't need to write it. Its derivative is in the top? Yes. Done. So the answer is ln of the denominator. So ln of the denominator. You don't need to waste your time to substitute back, and so on. You can do it much more faster in 10 seconds, not 2 minutes. Now look at this example. What is the integral of sine of x times cosine of x dx? The tricky part, the part that is so confusing, is this cosine of x. Rarely really in mathematics we see cosine of x, but we have this here. The first thing that comes to our mind is that we know that in substitution method, if we want to solve it something with substitution method, we choose the inside as u, and cosine x is inside of that outside cosine. So we guess that this should be u, and it is, because if we choose u to be cosine x, then du is negative sine of x, which we have here. We solve this for dx. Dx would be du over negative sine of x. And now we start substitution. So integral of sine x times cosine of cosine x, but cosine x is u, so we are using the substitution. And dx is du over negative sine x. Sine x with sine x cancels. What remains? A negative, cosine u, and du. Move the negative to the outside. Don't waste your time. Move it to the outside. Then you have negative integral cosine u du. But what is integral of cosine u? Sine u. This is a very famous formula. Integral of cosine is sine. So negative sine of u plus c. But u originally is this, so the answer is negative sine of cosine x plus c. This is the answer of that integral. Move to the next example. What is integral of cosine x dx over 1 plus sine squared x? This example is a little more challenging than previous examples that we have seen so far. First, we think, okay, maybe u is 1 plus sine squared x, because this substitution usually works, and we have seen many questions it worked. But if we choose this, du would be derivative of this, but derivative of this would be 2 sine x cosine x dx. We have cosine x, but we don't have this, especially the 2 doesn't matter, but sine in numerator, so this shows that this doesn't work. Maybe you are thinking about numerator to be u. If u is cosine x, then you have du is negative sine of x dx. Don't worry for negative. Negative is just a number, it's a coefficient. So we are looking for this. But sine x, we don't have any sine x. We are looking for sine x times dx. We don't have any sine x times dx in numerator. We have a sine to the 2 plus 1, but this is not what we are looking for. So this is not going to work. So it seems that we are trapped here. Attention, in substitution method, we are looking for a function as u. So we want to choose something as u, such that if this is u, du, derivative of that u, is in our expression here. Denominator didn't work. Numerator doesn't work. So what we have to do here? Maybe now we have to try to choose not all of the denominator as u, only small part of numerator, just a part of denominator as u, not all of the denominator as u. So what is u? And attention, derivative of that u should exist. Can you guess what is u? The derivative of the u also exists here. So what is u finally? U is going to be sine of x. Because if we choose this as u, sine to the 2 would be u to the 2. Not all of this, only this sine, because derivative of sine is cosine. Now we choose this as u. Then du would be cosine x dx. Solve this for dx. Dx would be du over cosine x. Let's do the substitution. So this would be cosine x dx, but dx is cosine x times dx. Dx is du over cosine x, all over 1 plus sine x is u, so sine to the 2 would be u to the 2. This cosine with that cosine cancels, and then we have integral of du over 1 plus u to the 2. And now you should remember this formula from integral formulas. Integral of du over 1 plus u to the 2 is tangent inverse of u. And the reason that this formula is valid is that what is the derivative of tangent inverse or arctangent? Exactly 1 over 1 plus u to the 2. So integral of du over 1 plus u to the 2 is tangent inverse of u. So what is integral of du over 1 plus u to the 2? Tangent inverse of u. And in general, integrals in this form such that not only you have 1 here, maybe you have 3 to the 2, 5 to the 2. This is more general than that formula. So integral of du over, again, not 1, any number to the 2 plus u to the 2. The answer of this integral is 1 over a tangent inverse of u over a plus c. So instead of this formula, we can memorize this more general formula. Anyway, in this example, we need this simple formula. So integral of du over 1 plus u to the 2 is tangent inverse of u. But u originally is sine, so the answer is tangent inverse of sine of x plus c. I hope by watching this video you have learned a little more about finding the integrals of functions involving trigonometric functions. If you like this video, please subscribe to my channel and see you in the next videos.